Hello everyone, this is the second video on specific heat capacity problems. So last lesson we solved some simple problems. Today we want to go through a little bit more difficult question. However, same rule, we use same rule and same laws. Okay, let's see what's the question. If you pause the video and answer the question by yourself, it's better. After that, you can check your answer. So students add 100 grams of cold water. So I want to name this one number 1. My cold water is number 1 with a temperature of, so I can say if I want to summarize my question, I can say M1 equal 100 grams and T1 is equal 10 degrees centigrade. Okay, and it's 300 cube of copper. I want to name this one as 2, my second one. So I say M2 is equal 300 grams and T2 actually is 15 degrees centigrade. Okay, so the students added this water and this cube of copper to 500 grams of hot water. So this one is third one. I name it 3, so I say M3 actually is 500 grams and T3 is equal 50 degrees centigrade. Okay. What will be the final temperature? Okay, when they ask for final temperature, actually final temperature, it means after reaching to thermal equilibrium. I name this final temperature with TE. Assume that no energy is transferred to or from the surrounding. So as the first law of thermodynamics, if no energy goes in or out of the system, it means the total energy of system stays the same. So if, for example, hot water loses energy, heat energy, and then that copper and cold water gains energy, the total amount of gained heat energy is equal to the total amount of lost heat energy. As a result, if one of these loses 10 joule of energy, the other one gains 10 joule of energy. So we don't have any change in total energy of the system. So as a result, we can say Q1 plus Q2 plus Q3 is equal 0. It means if Q1 and Q2, they gain energy and Q3 is loss of energy, so it means these two are equal to this one. However, the one is positive, these two are positives, and this one is negative, but the total still stay the same as the law of conservation of energy. Right now, I write Q1. Q1 definitely is M1, C1, delta T, that is T final, that is T equilibrium, minus T1, plus Q2 is M2, C2, again T equilibrium, minus T2, and Q3 is M3, 3, T equilibrium, minus T3 equal 0. And then definitely my mass should be in kilogram. They are all in gram. I need to convert them to kilogram by dividing by 1000. So this one is 0.11. This one is water, and C for water is 4186. TE, I don't have it. T1 is 10. This is for Q1 plus. M2 is 300, that it means 0.3 kilogram. T2, because the second one is copper, is 380. And then TE, this is something that we want to calculate, and T2 is 15. Plus M3 is 500 gram divided by 1000 become 0.5. The third one, M3, also is water, so is 4186 T equilibrium minus 50 equals 0. You see, just the only unknown that we have is TE. Right now, just there are some simple math that we need to do in order to answer this question. Okay, so we go through this. So as you can see here, we have this equation, and then if it times this number by this number, and this one by this one, and this one by this one, we make it into this simple equation, and then we times this number by TE and also by 10. And this one by T and 50, and the same here. We get this equation and we add all TE together and all other numbers together. We get this equation, and then the simple math, you calculate your TE and it becomes 42 degrees centigrade. This is the thermal equilibrium temperature for oil. I hope it helps, and bye for now.